Good morning, sir.
What have we done last class? Yeah.
Temperature sensor.
Okay, right. Okay, so last class we have discussed about the temperature sensor. Okay, right. And I'm just only listing the various different types of temperature sensor. If I am, you can help me. So one was the thermocouples. Okay. Then was, tell me first, bimetallic strip. Then thermistor. Then
RTD.
Resistance temperature detector. Then
Thermodiodes.
thermodiodes and
Thermotransistors.
transistors. Okay, thermodiodes and thermotransistors. Okay, right. So these are the various different types of the temperature sensor what we have discussed. Okay, now we'll just continue and we'll try to finish this chapter today with some of the different types of the sensors which are going to be present. Okay, right. Now we'll try to understand what are called as the tactile sensors. Tactile sensors. Okay, something like this. Okay, right. Now, just observe. Any idea about tactile sensor, where it is used? Any idea where tactile sensors are used? Hmm? Any idea? Yes or no? Right. No issue. Okay, right. Now observe. Basically, tactile sensor are a case of what are called as the pressure sensors. Okay. Tactile sensors are a case of what are called as the pressure sensors. First thing. Okay. Right. Now, these are going to be used in the robotics end effector. Okay. Any idea about robotic end effector? Robots end effector? Any idea?
Which are used to grab something.
Exactly. Okay. The end effector are the tools which are mainly used to grab an object or to pick an object. Okay. Now, if you need to pick an object, okay. Now, what we require is it's just like the end effector is nothing but the hand of your the robot. Okay. So this is nothing but your hand of robot. Now the question is, how do you ascertain or how do you know that you have sensed a particular object? Okay, now upon sensing the particular object, then you are going to apply some amount of force so that you are going to hold the object and then move the object from one point to another point. Okay, so that was the requirement of what is called as a tactile sensor. Okay, That means this sensor is mainly used, okay, in the robotic hands to determine whether the hand is nothing but whether the end effector has comes in contact with that of an object. Therefore, in the end effector, we will be having what is called as a tactile sensor. Okay. Now, what this tactile sensor is going to use here? I wrote here PVDF. There are PVDF word is there. Any idea about PVDF? Okay, what is that? PVDF is what? Basically, it's a smart material. Okay, basically PVDF is a smart material based on PZT. Okay, based on piezoelectricity. Okay, so PVDF is nothing but what is called as piezoelectric polyvinylidene fluoride. Okay, so PVDF is piezoelectric polyvinylidene fluoride. Okay, now this is basically a concept of what is called as a PZT. That means it works on the principle of piezoelectricity. What is piezoelectricity principle? What is piezoelectricity principle? This tactile sensor works on the electric principle or piezoelectricity principle. Okay, what is that we have? What in the piezoelectricity?
When you apply a mechanical load, voltage will be generated.
Simple. Okay, so when you are going to apply a mechanical load onto any of the piezoelectric based material, the voltage, the mechanical displacement is going to be converted into the voltage. Okay, now the reverse of is nothing but is called as the reverse piezoelectricity. Okay, now this is the basic operation that we are going to use. Now in this is the basic principle of piezoelectricity. Now we'll come back to the tactile sensor. Okay, now in tactile sensor, what we'll be having? We are having two different layers of PVDF. Okay, right? So this is one layer of PVDF. Okay, please observe. This is one layer of PVDF, and we have another layer of PVDF is going to be present. Okay, so another layer of PVDF is present. There are two different layers of PVDF are going to be present, which is separated by what is called as a soft film. Okay, so what this soft film is going to do is this soft film, okay, is going to transmit the vibration. Means what now? Now just observe to this PVDF. Okay, now to the lower PVDF, what is that I have given now? I have given the alternate current as the input. Okay, now what is going to happen to this PVDF now? What is going to happen to this PVDF now? You are giving what is the input now? Input is the voltage. You are giving the voltage as the input to the PVDF. As per the principle of piezoelectricity and the reverse piezoelectricity, what is going to happen to this PVDF? What this will do? What is going to happen?
Deform.
Voltage. The lower PVDF. Okay, now observe the lower PVDF has an alternating voltage. Okay, applied to it. So this is the alternating voltage which is applied to the lower PVDF. Now, when you are going to apply this alternating voltage, due to the piezoelectric principle, the voltage will be converted into what? Converted into mechanical oscillation of this film. Yes or no? Okay. Results in mechanical oscillation. Where this mechanical oscillation will be moving towards? Who is going to take the mechanical oscillation? It goes up, na? Okay. So we have what is called. Are you getting my point?
Yes, sir.
Okay, means to say you are given, please understand, you are given what is called as the AZ input now. This is the input that you are giving. Okay, right. Now, what is this film is going to do? You are given the voltage. So this is the PVDF material. Once you are given the voltage, so this experiences what is called as the mechanical oscillation because of the piezoelectric property. Okay, this experiences mechanical oscillation, which will be taken by what? Which will be taken by your soft film. Okay, now when the soft film is going to vibrate, okay, means what is now? You are giving a mechanical displacement. Okay, so due to this, the intermediate film transmits this vibration. Okay, this intermediate film, okay, so this fellow is going to transmit this vibration to where? This vibration to the upper PVDF film. Okay, Now, what is that you are transferring now? Voltage converted into mechanical displacement. That mechanical displacement is going to be transferred to the PVDF. Now, what is the input for this PVDF? What is the input for this PVDF?
Mechanical.
Mechanical displacement. So the input for this PVDF is mechanical displacement, okay, which is going to be transferred. Okay, now what is going to happen now? Okay, when you give the mechanical displacement, okay, now what is going to come? What is the output now? What is the output here?
Volt.
Output is going to be what? Output is going to be voltage. Okay, right. Now observe. The output is going to be voltage. Now at this moment, okay, if you are going to apply a pressure, okay, if you are going to apply a pressure, what is going to happen? What is going to happen if you are going to apply a pressure? Up till here, you are going to get the voltage. Now assume that you are going to apply a pressure. Means the what you call as your the end effector is going to come and contact with the PVDF. What is going to happen to this output voltage?
Increases.
Increases. Okay, now because you have, from where are you going to get this output voltage? You have got this output voltage initially. Assume this is not there. Okay, initially you have got this output voltage because of the mechanical displacement transferred from what? Transferred from the soft film to the top PVDF. Now you have got some value of the voltage. Okay, now you are going to apply a mechanical force, okay, apply a force pressure onto this member. Okay, now this is nothing but the end effector, assume. Okay, so this is nothing but the end effector. When end effector comes in contact with the PVDF, this voltage is going to do what? The voltage is going to changes. Okay, now when the voltage is going to changes, what does it mean? What is the meaning of the change in voltage? Are you interested in, please understand, are you interested in knowing how much the voltage has changed, or are you interested in knowing only whether the voltage has changed?
Knowing whether the voltage has changed.
Okay, you are not interested, please understand, you are not interested what is the amount of increase in the voltage. Okay, so you are not measuring the force here. What is the importance of this tactile sensor? You are only measuring, or you are only sensing whether there is any feel, whether there is any touch has happened to the member. Are you understanding? So once the feel of touch is there, once there is going to be a touch of this PVDF, this end effector onto the PVDF, the voltage is going to increase. So therefore, increase in voltage, okay, or increase or change in voltage, okay, change in voltage indicates what? Change in voltage indicates what? Indicates some external member touching the object, okay, touching the object, okay, which is the principle of what is called as the tactile sensor. Are you understanding now? Okay, clear, right? Yes or no?
Yes, sir.
Okay. Now, is this only sufficient for you to pick the object? Is the tactile sensor only sufficient to pick the object? What you require, you have sensed it, that's all. Okay, is that feel of touch is sufficient for me to pick the object?
No, sir.
No. What do you require? What do you require? What do you require? Huh? Okay, assume, can you able to see the video now?
Yes, sir.
Yeah, right. Now just assume that, can you able to see what is that I am doing? Okay, right. Now by using your tactile sensor, you just touch this. Okay, just assume. Okay, I'm just holding it below. Don't worry about this. Okay, just assume that you just touch the object. Is this touching sufficient for me to move the object?
No, sir.
Okay, then what I have to do now? What I have to do now? What sensor are you expecting now to come into picture? Okay, anyhow you have sensed the object, fine. Then what you require in order to make this to go to the next one? Okay, remember, if you just move like this, what might happen? This might happen. Are you understanding? Okay, got it? Now what is required? You need to hold the object. Hold the object
From
firmly. Okay, you need to hold the object firmly. with a sufficient amount of the force, so that when you are going to move and place it somewhere else, there should not be a dislocation. There should not be a drop of the object. Therefore, what type of sensor do you expecting now? One more sensor now. After tactile sensor, what is the other sensor that you expect? You should supposed to have what are called as the force sensors. Okay. Remember, the end effector should be used. Okay. The end effector should be used in conjunction with. Okay. In conjunction with these two sensor. Okay. Right. Now, without any one, you can't able to carry out the operation. Okay. So you have to carry out for pick and place. Understand? For pick and place operation. For pick and place operation. Okay. So in conjunction with two sensors you have to use. Which are those? One is going to be your the tactile sensor. This is used for what? This is used to check whether. This is used to check whether.
The object is touched or not, sir.
Whether.
Whether the object is touched or not, sir.
Yeah, whether the contact has been made. Okay. So contact established or not. That's all. Okay. Established or not. Okay. So for this, you are going to use tactile sensor. Then you use one more called as the force sensor. This is used to measure. This is used to measure what? This is used to measure whether enough. Either enough force has applied. Understanding or what? Okay. So whether enough force has applied. Okay. Right. So this is the meaning. Now, what are the force sensor? What are the force sensor that you are having? Any idea? Any idea about force sensor? Yeah. What are the force sensor? Okay. The basic one what we are going to use is called as the load cell. Okay. So what is load cell basically? Right. So this is going to have something like this. Okay. Okay, right. Now it's a small entity. Okay, I'm just rating it as big. Okay. Now you are going to apply what? You're going to apply the force. How will you measure the force? You are using the load cell. The load cell is a force measuring device. What I am going to have is I'm going to have one strain gauge here, one more on this surface, one more on this surface, and one more on the back side. Can you able to understand now? Okay. So these are the four strain gauges which are going to be present. Okay. So these are the four strain gauges which are going to be present. Okay. So right. So now we are moving on to the force sensor. The commonly used force measuring device is called as a load cell. So basically it is based on the use of electrical resistance strain gauges. Okay. Now when the strain gauges is going to be used is to measure smaller amount of displacement, Okay. Now what is going to happen is when this is going to be a cylindrical tube. Okay. So in the cylindrical tube on the top side and the bottom side you have a flat surface where you can able to apply the load. On the cylindrical surface you are going to have four strain gauges embedded uniformly across the circumference. Okay, uniformly across the circumference you are having four different the strain gauges are going to be present. Okay. Now when the force is going to apply, what is going to happen? When the force is going to apply, what is going to happen? The compression is going to occur. Yes or no? Okay. The compression is going to occur. That is, this will come down. Okay. So compression is going to occur. Now the amount of compression, okay, is going to make, okay, now you have force. Force made what? Force resulted in what? Force resulted in compression of what?
What, sir?
No. Force was converted into what here? Compression of cylindrical tube. Okay. Now, question is, can you measure this? Can you measure this compression by using mechanical device? Can you measure this small compression by using mechanical device?
Yes, sir.
Okay. There is a small amount of compression. Yeah. So this is a small compression. Okay. The smaller value. Can you use the extensometer here?
No.
No, sir.
No. Okay. Can you measure this? The answer is no. So what are you going to use now?
Strain gauges.
Strain gauge, sir.
Strain gauges. Okay, you are going to use the strain gauges. What is going to happen in the strain gauges? The resistance changes. Resistance of the strain gauges changes. Okay. This change in resistance make the voltage to change. Voltage to change. Now, from where have you started? What is your input value? The input value is the force. The input value is the force. Okay. Now, by going through all this, what have you obtained? What have you obtained? What is the output? Okay, the output is what? The voltage. Okay. Now, the change in the voltage, okay, the change in the voltage is a measure of what? The change in the voltage is a measure of what? What is the change in the voltage? Change in the voltage is a measure of what?
Force. How much
Force
is
that is
force?
going to apply. The change in the voltage is a measure of what is the force which are going to apply. Okay, right. So this is very, very important. Okay. Now we are going to understand, okay, the amount of load that is going to be applied through the change in the voltage. Okay, through the change in the voltage, we are going to apply the voltage which is going to be present. Okay, now this is something related to what is called as the force sensor. Okay, right. Then okay, then we have another small type of sensors. Okay, so we'll just go further with what is called as differential transformer. Okay, differential transformer sensor. Okay, right. Now the type of differential transformer sensor what we are going to discuss is what is called as the linear variable differential transformer, LVDT. Okay, right. So what is the basic principle of LVDT? Any idea? What is the basic principle of LVDT? Linear variable differential transformer. What is the basic principle of LVDT? Okay, it converts linear motion into electrical signal. Okay, so it converts linear motions into electrical signal. Okay. Linear motion is nothing but what? So you are going to give what is called as the displacement. Displacement converted to electrical signal means what is called as the voltage. Okay, remember. So what is that you are going to measure is the voltage. The voltage is a measure of what is called as the displacement. Okay, right. Now we just go understand how it is going to be differential transformer. Okay, now if you observe, okay, so this is going to be the transformer. Okay, I'm just showing the cut section of the transformer here. Okay, right. So we have okay, right. So we have what is called as iron core. Oh, sorry. Can you able to see? Hello?
No, sir.
No, you should have told, no? Okay, nobody has told anything. Okay, Right. Okay. Okay. So in between, we have what is called as this one, which is iron core. Okay. You can just make a note of it. Iron core. Okay. It's a iron core. Okay. Right. Now, you are going to give a displacement to this iron core. Okay. So this is the displacement what you are giving. Okay. Right. Now remember. Then we have primary winding. Okay. Then we have what is called as the secondary coil 1. This is again secondary coil 1, SC1. This is SC2. This is SC2. Okay, right. Now, if I am going to draw another simple diagram, so this is nothing but your core. Okay, right. So we have what is called as the primary winding. Okay. So to this, you are going to give the AC input. Okay. Then we have this is secondary coil 1. This is secondary coil 2. Okay. Right. Now please understand carefully. Now what you are giving is you are going to give the displacement to this. Means you are going to move this like this. Okay. Displacement. Now secondary coil 1 or the secondary voltage is going to be developed. It is called ES1. This is called ES2. Okay. Right. Okay. Now the same thing. Okay. I am going to take the ES1 separately and ES2 separately. But what I require is the voltage which is called as ES. Okay, that is the E out. Okay. Now how do I do it? Now again one more diagram I'm just making for your clarity. Okay. So this is core. We are going to move the core. Please observe. You are going to give the displacement by which the core is going to move. This will be as it is. Okay. Right. So we have what? Secondary coil 1. Okay. Now just observe what is that I am doing. Okay, I am interconnecting these two. Okay, what is that I am doing now is okay, I will interconnected this and I will take one arm of secondary coil 1 and I will take another coil of secondary coil 2 and I will measure what is called as the E out. That will be equal to ES1 minus ES2. Okay, just observe carefully. Okay, right. So this was the basic diagram. This is the basic diagram. Okay, and this is going to be the output diagram. Okay, now, okay, right. Now displacement is the input. Okay, and the output is now in this case only. Okay, so this is going to be your displacement. This is going to be your input and output is going to be what is called as E out. Okay, right. Now you tell me, okay, so how to calculate ES1 and ES2? Okay, what is ES1 and what is ES2? Right, now just observe, very simple. Okay, now when I am going to move the core I am going to move. I am going to give the displacement. When the core is going to move, what is going to happen? the primary winding coil. Okay, the LVD. Now, first of all, the LVDT consists 3 coils symmetrically spaced along the insulated tube. Okay, there are 3 coils are going to be there symmetrically spaced. The central one is called as the primary coil. This is the primary coil. On the either side of the primary coil, you have secondary coil 1 and you have secondary coil 2. Okay. Now, they are going to be placed in such a way that the iron core, the magnetic iron core, is going to move within this. Okay. Right. Now, observe now, when you are going to give an AC input, okay, when you are going to give an AC input, the magnetic potential is going to be developed through this coil. Okay, please understand carefully. When the AC input has been given to the primary winding, the core is going to get magnetized. Please understand. The core is going to get magnetized, due to which the ES1 and ES2 is going to be developed. Okay, due to which ES1 and ES2 is going to be developed. Okay. Now, if the core is going to be at the center, okay, right? Just observe now. Okay, so you have this combination. Okay, now the core, let me assume this is going to the central one. The core is at the center. Okay, so you have ES1 here, you have ES2. Then one more diagram. Okay, again ES1, ES2. The core is somewhere here. Okay, then one more diagram. Okay, the core is somewhere here. Okay. Okay, right. Now, case number 1. Okay, please observe. In case number 1, what is the effect of the presence of the core in the center of ES1 and ES2 is important. Okay. Now, what is going to happen here? Now, when the core is at the center, the magnetic intensity or the magnetic material, okay, or the magnetic intensity present in the core will be equally distributed to both ES1 and ES2. Are you understanding? Are you getting my point?
Yes.
Are you getting my point? So when the core is at the center, of the coils, ES1 and ES2 will have the same amount of electric potential. The same amount of electric potential will be developed by ES1 and ES2. In this case, ES1 will be equal to ES2. And what is this position is called? What is this voltage called as? E0 is equal to what now? E0 is equal to? What is E0? What is E0? Here it is there, no? E0 is equal to?
0, sir.
E0 is equal to ES1 minus ES2. E0 will be equal to 0. This is called as the null voltage. Okay, this is called null voltage. The position of the core, the core at which you are going to get E0 is equal to 0 is called as the null position. Okay, please remember. Okay, so just observe the position of the core at which the voltage will be equal to 0 is called as null position. Right now, at this position of the core, which is going to receive more amount of magnetic energy? At case 2,
Yes.
which secondary coil will receive more amount of magnetic energy?
ES1.
ES1. Therefore, what is going to happen to the ES1? ES1 value will be greater than ES2. Therefore, what is E0? E0 is going to be positive. Yes or no? Okay, E0 is going to be positive. Okay, right. If you move to the right side, what is going to happen? This is the core. Okay, this is the core, right? Because of the primary coil, okay. So you will be having the core at the right side. So which is nearer to what? Nearer to ES2. When it is nearer to ES2, what is going to happen to ES2? ES2 will be greater than ES1. Okay, therefore, what is the value of E0? E0 will be a negative. E0 is equal to ES1 minus ES2. E0 is going to be negative. Okay, right. Now, just observe now. Okay, what is that we are trying to understand from here is very important. Okay, right. Let's go to the 4th page. Okay. Okay, right. Let's go to the 4th page. Okay, right. Now, in the 4th one, okay, let me just write one simple diagram. Okay, now probably you might have observed. So, this is my displacement. This is my output voltage. Okay, right. Now, this is the position of the core. What is that I am drawing now is the core position. Core position central. Okay, right. So now, what is the displacement at this? The displacement will be equal to 0. Okay, right. Now, what I will do now is when I give a displacement to the right. Okay, now just observe. Earlier it was what? Earlier the core was like this somewhere here. The core was here. At this moment, it is 0. The voltage was 0 or E naught is equal to 0. Are you understanding or what? Okay. When I move this right, what is going to happen? What is going to happen? Correspondingly, the voltage is going to start to improve or reduce. Okay. Now this is going to. Are you getting my point?
Yes, sir.
Okay. Once you are going to the right, this and this is to the left. Okay, of the position. Okay. Now this is what is that you are giving now? You are giving the displacement. Once you are giving the displacement is directly proportional to what is called as the output voltage. Okay. Now that is the basic principle of what is called as the case of the LVDT. Okay. Right. Now next we'll just go with the small one called as the fluid pressure sensor. Okay, right. So, can you know what are the different sensors which are there? Pressure sensor. Can you name the pressure sensors? It is based on what? Based on the elastic. Based on the elastic element. Based on the elastic element, the pressure sensors are going to be present. Okay. I'm just having a meeting now. Okay. I'll just list down diaphragm. Okay. Right. You just note down. We'll continue. Okay. The bellows. And then capsules, board tube. Okay, these are types of pressure sensors. Okay, right. So basically, this uses what? This uses what are called as the elastic element. Okay, so this is going to use the elastic element as the member. Okay, now okay, right. So I think we'll stop at this stage. Okay, now we'll continue in the next class. Okay, right. So I'm just closing this. Okay, so you'll be in the same meeting. Okay, for the next class. Okay, right. We'll continue this in the next class.